the second solution to this problem is very similar to the first. You still realize that since it's a quadratic polynomial, it has two roots, p of x. So we say that this is x minus p times x minus q. Therefore, plugging it into this first equation, we get that this is going to be x minus p times x minus q minus p times x minus p times x minus q minus q is 0. Okay, so we have that. Well, now, realistically, again, we realize that one of these have to have a double root. So let's just assume that this is the one that has the double root. If that one does, then we know that upon expanding it, which we get as simply x squared minus p plus q times x plus pq minus p is equal to 0. Now, we can find the discriminant as this is simply b squared minus 4 ac. So, we can really factor it as this, since there's no 4 terms in a quadratic polynomial. So this discriminant is gonna be negative p plus q squared minus 4 pq minus p equals 0. Upon expanding this equation, we get that this is p squared minus 2pq plus q squared plus 4p is 0. Now, due to the previous equation, we can factor this by taking out a common factor like so. This becomes p squared minus 2q minus 4p plus q squared is 0. Now, you can apply the quadratic formula in this moment, as it is quite easy to solve, as we can just imagine this as the coefficient of this problem, or of that equation. So, therefore, p is equal to 2q minus 4 plus or minus the square root of negative 2 times 2q minus 4 squared, all of that. I should write it lower. Negative 2q minus 4 squared, and then after that there's then minus 4 times 1, since that coefficient's a 1, q squared. And all of this square rooted, and you divide that by 2. We get here that p is equal to 2q minus 4 plus or minus the square root of 4 times 1 minus q. And that's, of course, the square root, and you simply divide by 2. Now, it's easy to see here how you can divide by 2, as all these factors have all these terms have a factor of 2. And again, since we want the larger number, we choose the plus. So this simplifies to p is equal to q minus 2 plus 2 times 1 minus q, take the square root of that. When you add a q to both sides, it makes this a lot easier, as we can factor both sides by 2. So simply p plus q is equal to 2 times q, and then this is just minus 1 times 1 minus q. Yeah. And then you have to add that. Yeah. And, well, this is again getting in our way for a bit. So we use substitution, our good old friend. So let's let something variable k equals 1, the square root of 1 minus q. Okay. Then it appears to be that negative k squared is equal to q minus 1. So this equation, p plus q, that is equal to 2 times negative k squared plus k. Now, here we have this equation expressed in the sum of p and q, the sum of the roots there. So that's what we want. And the vertex we see again is 0 and 1. And since we want the average of the vertexes, 0 plus 1 over 2 is 1/2. So we have that. And we can again just solve for everything like the same thing again. Like k is equal to 1/2, q is 3/4, and p is equal to negative 1/4. It's just like the solution before. So when you again plug these into our first equation, we get that our answer is 5/16. And that is our answer.